And good afternoon, everyone. Or I guess good morning for those of us joining from the West Coast. Thanks for joining another ATS University. My name is Zach Allison with ATS. I'm a National Accounts Manager. For those of you that have probably attended this before, you're probably pretty familiar with the spiel, but my team works with engineers, architects, design build contractors, interior designers all across Canada and parts of the US to help ensure that you guys are getting everything you can out of the ATS spec tool. Spec tool is a product selections and product configuration system that after you've done selecting and configuring all your products and building, everything you need for your project, allows you to download a output format to put into your specification, whether or not that be a schedule on your drawings, a PDF package, or a written spec in various formats to match all sorts of different standards of writing a spec, from as detailed as you want to as light as you want. That service is all free for architects, engineers, interior designers, and everything, because it's paid for by our lovely sponsors and our manufacturers, such as SMS, who sponsors a number of different categories from, the electronic trap seal primers, water hammer arresters, right down to acid waste and neutralization tanks that are available on the system. So once you're done the presentation today, we'll provide a lot of different training on our manufacturer's products. And once we're done with that today, I'll show you how you can find the products that we're talking about on the spec tool, how you configure them, download the information you need to put into your project. One thing we did want to mention for any of those that are in the Toronto area, we are also partners with ASPE all across Canada and across the US. We attend a lot of different conferences, and locally here in Toronto, Owen is actually, are you still the president of ASPE Toronto?
Yes, I am. Yep.
Yeah, so Owen's been trying to kick that up and get that going. And one of our partners, Kinishan, at Hammerschlag and Jaffe, is also trying to get the ASPE Young Professionals up and going. So we are sponsoring a little networking event at Pogue Mahone's on Friday. We've already had a number of invites out, but if you would like to join, please feel free to reach out to me. I'll send over the link to the information. Anyone under 35, come on down. You get a networking as well as a nice headshot that you can put on your LinkedIn or anything like that. So we got a professional photographer coming in to do headshots, and we'll touch them all up and send them out to everyone. But also a nice little networking event at a fun venue. So come on down and hanging out with us for a little bit. That's kind of the housekeeping on that side done. One other thing I'll mention before I pass it over to you, Owen, is that, of course, this presentation is recorded. I'll be keeping an eye on any questions along the way, and I'll bring them up to Owen as we go. And at the end of the presentation, I'll show you how you can find the recording, how you can find the products that we talked about today. And of course, by the end of the week, we will have your certificate of attendance sent out to all those who've participated with us, so that you can self-report for your CPD hours or anything like that. I guess without any further ado, I'll pass it over to you. And thanks for joining us again.
Yeah, my pleasure. My pleasure. Thanks for the invite. As far as sharing the presentation, just want to confirm that everyone can see the screen.
Yes, sir. Looking good.
Presentation. Okay. Yeah, thanks again. Welcome everyone for joining us today. For those that I may have already met or have seen this presentation before, it will be a repeat with some tweaks, with, again, more specific to kind of like current events, things that I've seen in the marketplace. For those of you that aren't aware of SMS, our wheelhouse is all things corrosive waste. We do corrosive waste piping systems specific to IPEX across Canada, but this presentation is geared towards education. There is no sales pitch or spins here. Being the ASPE chapter president for the Toronto region, I always try to make sure that my presentations are, again, something that you can take away with, something that you can use in your daily tasks. You may not come across a lot of corrosive waste applications on a daily basis, but this should give you a good foundation moving forward as to what it is we're looking for with respect to the Canadian code. If there's any US folks on the presentation today, I do not have US content, but more than happy to work with my US colleagues to answer any questions should they come up, not specific to the Canadian code. So I'm the National Sales Manager for SMS, Smiley McAdam Summerlin out of Whitby, Ontario. I've been in the industry since 1997, again, mostly in the plastics. And our wheelhouse, my focus on the market, or in my career over the last 25 plus years, has been in corrosive waste and in the neutralization field. So we're going to talk about national codes. We're going to talk about the different piping systems. We're going to talk about a unit value comparisons cost-wise. And then we're going to jump into the neutralization portion of it. So I'll try to go through the piping portion of it fairly quickly, because I think the most important part is the neutralization. And you'll see why shortly in the presentation, because our code is, again, very specific when it does come to corrosive waste. And I do have the code references up here on the right-hand side. So to jump in on the piping requirements, what does the code say? So 2281 in the national, in the OBC, it used to be 7281, but where it talks about pipes and fittings to be used in a drain and vent for corrosive waste, it shall conform to. Definitions in our code: shall means must, and then it lists A, B, and C. A, I have stricken off, I'll talk to in a second. B is your borosilicate glass, and then C is your CSA 181.3. And it talks about specifically polyolefin and PVDF, polyvinylidene fluoride material. Those are the only permissible options. So I'll go through, so if you've got considerations for PVC, doesn't fall under that CSA 181.3, or the B, or the first one, which is the silicon iron casting. The reason I point that out, as I mentioned, I've added some things to my slides from what I've seen in my travels across Canada, talking to engineers about corrosive waste, and different parts of the country. Somebody would say, "Hey, you know, what about this material? It says it's for corrosive waste, and it's CPVC material." So this, and again, this is not product bashing. This is pointing out some of the nuances. Spears, for example, a great company that have been around for a long time. They do have a CPVC corrosive waste product, as shown here in their flyer on the right-hand side. And you can see in the red that it does mention certifications to a CSA 181.2. So it's fine in some aspects, but not for corrosive waste here in Canada. If you look through, again, on the left-hand side, the requirement is CSA 181.3. So that 0.2 and 0.3 difference is very, very important, because it's specific to the material. So just to kind of back up a little bit, CPVC, PVC are solvent welded systems. So they are, by nature, changed in their properties to weld them, to solvent weld them together. Using a solvent, it changes, it liquefies the pipe and the fitting surfaces. That's where you get solvent welding, is because the actual solvent is used to soften the material to put them together. That, the difference, so PVC and CPVC fall under the material category under our code of CSA 181.2. And for specific corrosion resistance requirements and chemical resistance, the code is specified 181.3, which is polyolefins, polypropylene, polyethylene, and PVDF. That is why, because they are inert to these solvents. So I just wanted to touch on that. So just caution with some of the US or CSA requirements that you, or CSA listings that you might see. It's very specific, as you can see in that 2281. It also talks in our code in 2553, venting. And I know it says that it's for drainage piping and dilution tanks. Dilution tanks are, the word dilution is used interchangeably with neutralization in our code, but Venting systems for drain piping and dilution tanks conveying corrosive waste shall extend independently. So what does that mean? At no point does your vent system or your vent for your corrosive waste drainage tie into your standard DWV. It is independently vented into outside air. You can collect them as a corrosive waste system and have one stack, but it is to be looked at as a standalone system. So you have your corrosive waste drainage and your corrosive waste venting. And the reason for that is if you don't use corrosive waste vent materials and you tie into cast or copper or something that is not corrosion resistant, that corrosive vapor will just condense again from a vapor into a liquid. And now I have a corrosive waste liquid that will corrode your vent piping as well. So these systems are independent on the DWV side as well as the vent, independently venting through roof termination. And lastly, vent sizing. So vent sizing, again, for sewage pumps, dilution tanks, which again is used interchangeably with neutralization. And the point here of note is point 2 in 2577. The size of every vent pipe for a sewage sump or dilution tank, neutralization tank, shall not be less than 2 and not need to be greater than 4. So what that means is even if you have an at source under the tank neutralization tank or dilution tank, it needs to be vented, and a minimum vent sizing for that tank is 2 inch. All right, and finally, plenums. Plenums come into play in all commercial structures. So be cognizant of that, even though a pipe may say it has a flame spread or it is flame retardant. In the code, it's very specific to a 2550, which is, I believe, if memory serves me correctly, under the CAN ULCS 112 requirement. So that's flame and smoke. So it says all materials within that concealed space have a flame and smoke rating of 2550 or less. So on the piping side, there was that A, B, and C. A, I've crossed off, as you recall, and it's a my apologies, it's a cast iron type system, but it was called Dur iron. It's a high silicon iron casting product that was the inception product over 100 years ago for corrosive waste. So it was formulated to have a higher silica sand content, and that silica sand does have a higher chemical resistivity. So again, it was discontinued by the manufacturer in the U.S. in April of 2016. So every once in a while we'll dig it up like old dinosaur bones on a project. So if you see this corrosive waste piping, it's heavy, looks like cast iron's got a bit of a glass fleck to it. It does kind of have this little bit of a, lack of a better description, a bit of a sparkle. Anyway, it's not available anymore. So now what we have to do, if you do encounter Dur iron, is to transition to it with different coupling, like Mission coupling, Dallas couplings, different types of mechanical connectors, but it does not exist anymore. So if it is in your specification, if you have it in your master spec library, Dur iron, I would suggest removing it so there's less confusion. So the only non-combustible DWV corrosive waste that we have in our code here is borosilicate glass. So for your plenums and for your vertical shaft applications in a corrosive waste, we have glass as the only option for vertical shafts. And it does, because it's non-combustible, also meet the flame and smoke. I'll go into that a little bit further in a couple slides here. But glass is available up to 6. It is made by skilled tradespeople. So it's one of the things that are often not quite understood about glass is that it is made by skilled tradespeople on jigs. So they would take a piece of pipe from the blast furnace, form it into a piece of pipe, and then make it into small sections, flare the ends or bead the ends, and then using a torch and a jig, they would make a 90, a 45, 22.5. For Y branches, etc., they would take another piece of similar material and using carbon rod, they would weld that branch together. So basically what that's boiling down to is cost. So I'll talk about unit value comparisons later, but glass is a readily available material. It is not obsolete. You'll still find it in a lot of facilities. And it does, if you think of a lab environment, it does offer the most, the broadest range of chemical resistance. If you think of a lab environment, you've got beakers, flasks, test tubes. Those are all made out of that same material. It's a borosilicate glass material. So again, that's some food for thought. It is joined, so you cut glass piping, and it starts off with two plain ends, or sorry, my apologies, two beaded ends. And once you cut it, now I have a bead and a plain end. So the way you join glass is by way of bead to bead and bead to plain. So this stick drawing here shows you basically how that goes together. You have the flared or the bead ends of your fittings or your glass pipe. And if you cut the glass, or if you're transitioning to polypropylene or PVDF, the bead to plain is used for that connection as well. So plastics, the CSA 181.3, so of the A, B, and C, I've covered the borosilicate glass and the dur iron. This is the plastics options for corrosive waste here. All plastics, regardless of their flame and smoke, are classified as combustible. So they are in their own category with respect to fire stopping and limitations within the building space, like a plenum, for example. So that said, plastics are consumed in a fire. They do have to have properties that show lower smoke or lower flame spread in a commercial structure. Back in, I believe it was 1999, there was no plastic option for corrosive waste. It was dur iron and glass and whatnot in our Canadian code. The provision, so polypropylene and PVDF were added into our code in 1999. It used to be under 31516. It's now 31519 international. And what this section is detailing is there was a weighing. There was a weighing or discussion around corrosion resistance or chemical resistance of plastics and the flame spread requirements for a non-combustible structure. So I won't dwell on it too long, but there had to be a provision made in our code to permit polypropylene's usage in a non-combustible building because it does not meet the flame spread rating for non-combustible buildings. I don't know if you're familiar with System 15 and XFR on the PVC-DWV side. That's why you can't use ABS in a building that's classified as non-combustible, because it doesn't meet the flame spread rating. PVC does meet flame spread, polypropylene does not, but you can see here polypropylene pipes and fittings are permitted to be used for drain, waste, and vent for the piping of, for the conveyance of highly corrosive materials and for piping used to distribute distilled or dialyzed water. That's your pure water as well. In laboratory or hospital facilities, in a building required to be of non-combustible construction, provided that the caveat or that provision is the building must be sprinklered. So essentially, the authorities having jurisdiction do not need to see a piece of paper that says polypropylene meets the flame spread rating for a non-combustible building, as long as the building is sprinklered. If that building is sprinklered, polypropylene is exempt from needing to meet the flame spread requirements because its corrosion resistant properties kind of outweigh, if you will, the requirement for that flame spread if it's a sprinklered building. B, the piping cannot be located in a vertical shaft because a vertical shaft, nothing in that shaft that is combustible is permitted, and it has to have a fire separation. So again, that's the nuts and bolts of all of the pipe and fittings. So you have your borosilicate glass and your two options for plastics, polypropylene, which I just discussed, and PVDF is the other material. PVDF is the material like the XFR that meets a flame and smoke. So, for example, if the building is an old building and reconfiguring an old geography room to now be a science class, and uh, the school had no sprinklers. You could not use polypropylene in that application, so now you're down to choosing either PVDF or a glass material. So PVDF meets flame and smoke. It does have a flame and smoke listing. I hope I've kind of conveyed that in a manner that's understandable. Special provisions for polypropylene is what you have to think of. There's two ways of joining polypropylene and PVDF, either fusion or mechanical. And again, we're talking sometimes terms flame retardant polypropylene, non-flame retardant polypropylene. It's still polypropylene. It does not meet the flame spread. It's just it's got to be a sprinkler building. And then there's PVDF. PVDF meets the flame and smoke for non-sprinklered corrosive waste applications, plenum applications, but it too cannot be used in a vertical shaft because it is a combustible product. So unit value comparison, if the glass has a control factor of 1, PVDF is fairly close. It's about 25% less than that of the value of glass in a system. And you can see why, if you're looking at a corrosive waste system, you would look towards a polypropylene as a main focus. And again, checking temperatures, corrosion resistance, building limitations, etc. Polypropylene is your most cost-effective application. And you can see why dur iron is no longer made. It was 3.5 times that of glass, where now in today's market, it would be 10 times more costly than a equivalent project in polypropylene. So
just to kind of take a little pause there as we finish off recapping the glass aspect.
Yep.
You know, the borosilicate glass widespread usage, one of the few that is actually available for the vertical risers if they're using it there.
Correct.
But there's a little bit of a cost bump associated with it.
Yep.
Whereas, like you mentioned, if you're doing the retrofits, and I think converting a classroom in a school is a great example. It comes up all the time. You could, depending on whether or not it's sprinklered, you might have more options. And then, continuing on it,
right.
If you're doing new construction, you can do a combination of these, right?
Correct. Absolutely. So to reiterate the sprinkler, non-sprinkler, because there was a special provision added to our code to allow polypropylene for this application, if that criteria is not met, it doesn't have sprinklers, then you do have to comply with the flame and smoke requirements of that non-combustible structure. So, and yeah, glass is expensive because of not only the material, but because there's a lot more labor, whereas the plastics would come out of an injection mold machine. So glass, that's the imparted cost on glass is that labor portion.
You showed me a video one time of making the glass. Very interesting, actually. I think, wasn't there like a how it's made on it?
Yeah, there's even cutting glass. You use a diamond wheel on the inside and a torch to create a thermal shock, and that's how glass is cut on site. But yeah, it's these blast furnaces for glass manufacturing. They run 24 hours a day, 365 days a year. So this market is small for most glass, for borosilicate glass manufacturing. So it's a pretty. I'm still waiting for my invite to go to Germany to see how this is all made, but anyhow,
I'll come along with you maybe next September.
For sure.
Yeah, I haven't seen any other questions come in, so I guess we can move on to the next step.
Sure. So another general requirement for corrosive waste in general is exposure materials in our National Code 2211, where basically it states we're 2, materials and equipment used in the drainage system where excessively corrosive wastes are present shall be suitable for the purpose. And I bring this up because if you've got corrosive waste system, you're concentrating on chemical resistance of the pipe and the fittings, and then you're joining to something else. Why use a typical mechanical joint rubber coupling? It's the weakest link. So you've got to put in the due diligence to make sure that it's suitable for the application. That said, there's couplings like this Dallas coupling, mission couplings in the center, or maybe you have to transition using flanges or male-female threading. In these systems, there's also pH monitors. So pH monitoring, do you want to know what your effluent pH is on discharge? I'll talk more about that in the neutralization, but these are systems. So you've got your DWV system, your venting, your drainage, and now I've got pH monitors and other equipment tying into a BAS system, et cetera, et cetera. Where you're going to find corrosive waste applications, your typical high school, university type of a lab, hospital labs for sure, industrial applications if they've got chemical process washdown, pharma is obvious, and surprisingly, a lot of people aren't familiar with the food and beverage requirements for corrosion resistance, and that's again chemical sterilization of vats, things of that nature. So a lot of detergents, a lot of soaps. Sometimes you cannot discharge because of the pH discharge limits have to be dealt with, and I'll talk about those here momentarily. But just as a quick recap, you have to comply, thou shalt conform to A, B, or C. So we're left with polypropylene, PVDF, or glass as our three piping options. You have to look at the completeness of the product. Is it a combustible or non-combustible option? Do I have plenums? Do I have vertical shafts? Do I have temperature, chemical issues, et cetera? So once you tick those boxes, then you can select the most appropriate material for those applications. So neutralization. So that kind of covers the pipe and fittings portion of it. The neutralization part of our code is very specific as well, similar to the pipe and fittings. But the pipe and fittings, you have 2281, 31519, 3643, 2553, and 2557. Those are your, again, vent sizing, pipe material, plenums, etc. But in a plumbing system, it also takes into consideration vertical shafts, fire stopping, slope, etc. So the pipe has a lot of attention. So the authority having jurisdiction, going to the site, whether it's the building or the plumbing official, they're looking at this with some knowledge of typical piping systems. Whereas when it comes to neutralization in the national code, this is what it's giving us. So 2444, neutralization and dilution tanks, specifically where a fixture or equipment discharges corrosive or acidic waste, it shall, again, shall means must, discharge into a neutralization or dilution tank that's connected to the sanitary drainage system through a trap or indirect connection. And sadly, the detail we have to follow is in 2 here. Neutralization and dilution tanks shall have a method for neutralizing the liquid. It doesn't say how big, what it looks like, etc. So that should indicate to you that these are engineered design systems. So you have to take all of the components of this system and consider, do I use system A, system B, what type of system do I need, how big is it, et cetera, et cetera. So this part of the code is telling us that we need to neutralize prior to discharge, and you have to have a way of neutralizing the liquid before you discharge. So the term corrosive waste is used and has been used through this whole presentation. It's used in our code. What is it? It's your sewer use bylaw, or the jurisdiction in which this project is, or this building is being built or exists, is very specific. Every municipality has a set limit or parameter for pH discharge. So what you have is a municipality saying we will accept a discharge maximum pH 10, minimum pH 6, 5.5. And if you are outside of those parameters, your waste or your effluent is considered corrosive. And you have to get it within that permissible discharge window for the municipality to be acceptant of that discharge. Some municipalities do not permit, I'll show in the second slide here, neutralization by way of dilution. They specifically spell it out. Municipal bylaws will often say neutralization by way of dilution is non-permissible. So my background is in biology. When I was going through my education, one of my profs said the solution to pollution is dilution. And what we used to do is pour a beaker of whatever we had and turn the cold water tap on. So sadly, that is kind of a not in my backyard approach to dealing with something, because it's just flushing it out of the facility. It's not actually treating it. And this section here, section 5, was taken from was taken from an actual sewer use bylaw. I think it was the city of Toronto where I grabbed it from, but just as a reference. So no person shall discharge directly or indirectly or cause the permit the discharge or deposit of sewage into blah, blah, blah. Basically, it says in the end, has been added to the discharge for the purposes of dilution to achieve the compliance. So they do not want you to use waste of natural resources, let's say fresh water, in excessive volumes to dilute your acidic or caustic effluent. So I'm going to throw you all back to grade 7 science class and look at this periodic, sorry, not the periodic table, the pH table. Neutral is 7. So when we talk neutralization, we're not trying to achieve a pH 7 neutrality. We're trying to, again, get within that permissible window of the that the municipality sets. Every change in pH from 6 to 7 is what's called a decade unit, or 10 times in concentration. So a pH of 6 is 10 times more acidic than a pH 7. pH 5 is 100 times more acidic than pH 7. So if you follow that scale back, what does that mean if you were considering using the methodology of dilution to change a 1 liter pH 1 using dilution to pH 7, for example? You would need 1 million liters of water, 1 million liters less 1, to make that a pH neutral solution. So it's just a waste. It's not the way of thinking of neutralization. It's a waste of water. There's huge volumes. So the way you think of neutralization is by way of 2 methods: passive neutralization and active. So your passive is for acids only, because you're using a solid alkaline, calcium carbonate limestone, and it will neutralize acids. And I'll talk about sizing and whatnot, but that's a limitation. So if you have an effluent that's caustic already, limestone's not going to do anything for you. It's not going to neutralize a caustic. It will only act on an acidic effluent. And then you have an active neutralization system, which uses alkaline or basic solutions. It is a liquid and injects by way of pump and agitation to create a neutral or permissible discharge. So typical gravity systems you would see on the left-hand side, kind of line drawing there, you've got your inlet of your acid coming in. It goes through and percolates through the limestone. It's called dwell time, that certain amount of time to have that acid changed its pH. And you can see that it's got a 5.5 to 6.5 discharge. Tank sizing. So I guess, Zach, there is calculations that I'll share on the neutralization side of things, make this calculations available to folks. But what we're talking on, when we're talking passive neutralization, it's fixture counts. So essentially, you have to, using gravity limestone system, we use a minimum of 1 gallon per hour of retention time for every fixture unit in the system. So what you're trying to do is have that liquid in contact with the calcium carbonate limestone for a minimum of 1 hour as it works its way through the system to achieve that permissible discharge pH. So for example, if you've got a lab that you've got 60 sinks, if you look up in that table previously shown, it's 1.5 fixture units per sink, and that's going to give me 90 gallons of functional capacity. I'll talk about functional capacity in a minute. So in the above example, I would specify an AN100, or I'm getting close to 90. There's probably no such thing as a 90-gallon unit. They're typically in different 25-gallon, as they get larger, 25-gallon ranges. So you would specify in this case an AN100 with a functional capacity of 100 gallons. So that tank would probably be in the 42 by 54 inch size range. For an existing tank, so if you're going into a facility and you have an existing tank and you want to know what its capacity is, it's not it's not a real complex calculation. Your volume of a cylinder, pi r squared h, to the h being the outlet invert height, and that gives you your volume in cubic inches. You convert that to gallons, and we use a 50%. The larger the aggregate, typically your 1 to 3 inch aggregate size, and just based on past experience, that works out to about a 40 to 50% liquid displacement. So you take your volume, you subtract 50%, and it leaves you your functional capacity. How much liquid can it actually hold?
And that is one of the common occurrences of, like, issues as this equipment is specified. It's one of the very straightforward pieces, right? Match your GPM to the unit, but or your gallons of storage to a unit, but not all the manufacturers list their functional capacity as their model number. So it is one of those easy overlooks where you think you're specifying, an AN100 or an equivalent from another manufacturer's 100-gallon version, but you're actually specifying a 50-gallon functional capacity from some manufacturers because their nomenclature is just slightly different. So
exactly, and that's why
a good thing to double check.
For sure. And thanks for bringing that up, Zach, because yeah, once you do this calculation of taking your fixture unit, multiplying your sinks by a 1.5 fixture unit, you're actually getting how much capacity does my tank need. So if you specify a tank that's, in this case, 100 gallons, but then I add 1,000 pounds of calcium carbonate limestone to it, my actual functional capacity of that tank has now changed by a factor of 50%, because that tank will not hold and will not be large enough to do the job that it should. I'll go into that a little bit more here in a minute. So once you get your volume, pi r squared h, the divider is 277.42 to get imperial gallons, or 231 for US gallons, because it's giving you an answer in cubic inches. So as Zach had mentioned, think of it as a hole in my bucket. If I have a tank that's 100 gallons empty right to the rim, if I drill a hole in it for an inlet, an outlet, and a vent, and then I fill it with rocks, my quote unquote 5-gallon Home Depot bucket or my 100-gallon tank is no longer capable of holding 100 gallons. So that H in your pi r squared out H calculation is your outlet invert, and then your volume that it gives you, you have to use a 50% displacement to give you your actual functional capacity. What is that functional capacity? Exactly that. How much liquid can that tank hold? So for an existing tank, same thing, pi r squared h, and then you'd convert it into imperial or US gallons. Most companies will say an AN65. You can see the first number there, the 142. That's the empty tank size. So that tank that is 36 by 48 will hold 142 gallons, but the 65 is its functional capacity. So just be cautious of that. That highlighted red section is your functional capacity. So you have a few options. You have above grade or below grade. This is a typical system. You can see a lot of these pictures, they show a smaller tank upstream of the larger neutralizer, and I'll explain why that is important shortly. That's an interceptor, and there could be limitations in your building, your door sizes, how big is the tank. Sometimes you need to consider using multiple tanks. You can see here on the picture on the right, you have your interceptor, and then I have a 2-tank system. So you think of it as a battery. your capacity can be divided into multiple tanks. If, for example, a 48 by 84 tank is too big to fit through the building that's existing, you don't want to start blowing doors open. So maybe I make a tank, or I specify a tank in multiple series that are able to fit through the hallways and into these facilities, into the doors. These tanks are not off the shelf typically. So when you specify something, that's important to put your detail in your spec, the diameter, the height. If you can specify, obviously, if it's your functional capacity, or at least spell it out, all of the detail in your spec. So your diameter, your height, your volume, your functional capacity, fixture unit capabilities, et cetera, et cetera. All of this will help make sure that you're getting the correct tank for your project. So all of these systems are customizable. Some health facilities now require N+1 for critical infrastructure. So hospitals and other facilities that have an N+1, sometimes you'll see something like this. You'll have a bypass type of a scenario, or something similar. Sometimes maintenance requirements on an interceptor, you'll have a couple of them in series or series parallel with diversion valves for maintenance purposes. Again, a lot of companies will help you assist. That's kind of what SMS does. We help do a lot of the design assistance to make sure that you're getting the right tank for the application. Fabrication. All of these tanks are fabricated. So if your space is confined, some manufacturers offer the option of having an internal interceptor. So if you don't have the space to have a small separate tank, building one within the neutralizer is also an option. You do sacrifice a little bit of internal space, so your tank specification needs to be a bit larger in its diameter to accommodate that functional capacity. Flush with floor applications, it's identical to the above grade, but what happens is there is a maintaining of the functional capacity. So your liquid level, that's your functional capacity, but you also have to take into consideration your slope. So if that tank is no longer able to fit in this room, I've got to now move it somewhere else. You've got to take your developed length of your piping inlet and figure out what your changes to your functional capacity need to be. Sorry, not changes to the functional capacity, but changes to your tank dimensions to maintain your functional capacity. So that's your passive side. You have your above or below grade limestone systems based on fixture unit calculations for a specific dwell time, 1 hour per fixture unit in the system. When it gets to neutralization by way of injection or active neutralizing, you essentially have your untreated liquid coming in. You've got pumps that dose acids or caustics. You have an agitator that mixes it all together. You've got level sensors, pH controllers, etc. And then you can see on the right-hand side, you have your treated effluent that is within permissible parameters. So this is a very wordy slide, but basically how there's three methods of going about an injection system sizing. If you know the gallon per minute rate, you take that GPM. ASPE has a recommendation of 10 minutes of dwell time, and we have found 15 minutes. It doesn't change all of your components, but it adds a little bit of time for neutralization. So the recommendation from SMS and myself over the years has been a 15-minute retention time. So you take your GPM, multiply it by 15. That's how big your tank needs to be. It's pretty straightforward. If you don't know your flow rate, our code has the following calculations, which I'll show you. Option 1, if there's two options. If your calculated fixture unit is above, I believe it's 260, use method A. If it's below 260, use method B. So for example, you have 224 sinks, 1.5 fixture units. I've got 336 fixture units. If I want to add future, or, I want to add some diversity, some safety factor, whatever, you can add that at this point. So I come up with a 504 fixture unit calculation. Here's where it talks about in the national 24105B and 2432. So when a load is more than 260 fixture units, the load is 9.1 liters for each fixture unit. So for example, that 504 fixture unit example, 504 times your 9.1 divided by 900, because the hydraulic load of 900 liters for every liter per second flow is the math here. I'm going to share this obviously with you guys so you don't have to memorize it, or take screenshots. 24103 has that 900 liters for each liter per second. It gives me a GPM flow rate. So essentially 80.77 US gallons per minute. If I want to hold that for 15 minutes, I multiply that by 15. Now I know that my tank needs to be 1,200 gallons of capacity. So that's approximately 64-inch diameter by 123 inches tall. So these systems do get large. But again, a 200, what was that? 224 sinks with a 50% future. That's a big system. So again, diversity. Diversity is another thing. So I'm calculating it based on worst case scenario. Sometimes typical 50 to 70% is what the diversity is used. So not all sinks are being run at the same time. So instead of designing it for a 100-year event in this lab, you can design it pretty comfortably at 50 to 70% diversity. Second option, so if your fixture unit is below 260, as per that 24105, the load less than 260, a round figure of 2,360 liters is used. And again, under 24132, 900 liters for every liter per second. This scenario, if I've got 135 fixture units as my calculated volume, my flow rate, sorry, I've got 41.5 gallons per minute, dwell time of 15. Now my tank size is 623 US gallons. And if I take a 70% diversity as an example, my tank size is 436 gallons. So I hope that makes sense. Easiest is if you know your GPM. Sometimes if it's in a lab, you've got some machinery is discharging, or dishwashers discharge at X liters per minute, or a volume that's calculatable as far as the supplier. You just multiply that by 10 or 15 to give you your volume. Injection systems may look like this as a skid, or like the one on the right where you have multiple components. You've got your dosing pumps, you've got your reagents. So one tank will have an acid, one tank will have a caustic. You can see on the left-hand side those two blue pumps on the left, on those two white tanks in a spill tray. They all kind of look the same. They have to have the same components. But yeah, I think the one on the right is Sunnybrook. That's a Sunnybrook installation there. Just some other examples of what they might look like. You can see in the center image there is a ultrasonic level indicator, so you could connect that to BAS. So as that reagent is dropping, it will alert the maintenance facility, say, okay, I got to go top up my caustic or top up my acid reagent. They have to have an agitator. And again, you can see on the right-hand side, there is a matching inlet, outlet, interceptor tank with that stand. If you don't specify the stand, you'll get something weird and wonderful. You get an interceptor stacked on skids, or they'll make whatever it is that's cheapest. So just to kind of move on the injection systems here, again, there's lots of variety. The systems do get large and complicated, but for the most part, the simple hospital, university, college applications are very straightforward, similar to these types of systems. When you get into a big pharma application, that's when you'll see these big skid type systems. Level of scrutiny. If you specify a neutralization system and you've gone through fixture units and you're sizing a system, the inspector will only see this magic box. They don't know if it was sized properly, if the contractor has followed the spec, if it's right. So the inspector sees, okay, I know there's supposed to be a neutralizer, but they're not going to stand there and make sure that it's neutral on its discharge. So it's up to the specifying engineer to scrutinize equal submissions, because there is no code. These are engineered solutions, so you can't say, oh, it must be compliant to CSA or NSF or ASTM. These are designed specifically for volume and pH control. Things like, how is it built? Does it look like a Rubbermaid garbage can with rocks in it? Like, how is it going to seal its vapors? Does it use stainless steel hardware? Ask for the details on how it's constructed, below grade versus above grade. So you can see some of the other ones here. I'll back up. You can see that this has got a very obvious gasket. On the detailed drawing on the left, it shows that it's got some compression of a gasket, it's welded, etc. And same thing, it's showing the side profile of what that looks like. And then you have somebody says, okay, well, I have a system that has that's capable of a neutralization system, and this is what it looks like. But is it actually an equal? Has it been made for the intended purpose, is to be buried in the bowels of this facility for the next 30, 50 years? So is this an acceptable alternate? A garbage can filled with rocks? This is essentially what you get. Is the video playing? So this is a system that has very thin plastic. There's no gasket seal. And this room is this is copper pipe that has been corroded within this room because of the escaping vapors within this facility. So if you have a tank that looks like a tank, but you can't seal, you saw how thin that plastic material was, you end up with, so you can see the thinness of this wall versus something like this. There's no way you're shaking that and moving that with your hand. So level of scrutiny is kind of what I'm trying to hammer home here. It has to be, suitable for the purpose. Are you using stainless steel, EPDM gaskets, et cetera, et cetera? They're not all made equal. And no disrespect to my contractor friends, they'll take the cheapest option for the most part, because as long as the engineer says, yeah, okay, this is an equal alternate, they might be saving $1,000, but you'll get the garbage can versus the system that's been originally conceived. So sediment interceptors, I just want to touch really quickly on sediment interceptors, whether they're above grade or flush with floor. The intent of that device is to protect this dip tube. So this dip tube is required for all gravity-fed neutralization systems, because what it does is it prevents laminar flow. Instead of it coming in and going straight out, you have to force the liquid, through that limestone for that prescribed amount of time. So that dip tube, if it gets plugged, it's surrounded by, let's say it's 1,000, 1,500, 2,000 pounds of calcium carbonate aggregate, and there's no way of accessing that unless, again, you specify it's got to have a clean out at the top of that dip tube. I want to have an interceptor up front of it on a stand that's collecting all of this debris. Interceptors, as I mentioned in the previous slide, can be added into the tank as an option, an integral interceptor, so you don't have to worry about the additional space. But this is what you're trying to intercept, especially in a university or college type of lab, even in hospitals: broken glass, litmus paper strips, and Eppendorf pipette tips. So that's what you're going to see blocking these systems. This is a very typical college lab, and luckily it was glass piping, and we were able to see what was being intercepted in the P-trap upstream. They didn't have an interceptor. So their tank was getting plugged, and you can, in the next room, you could see why. It's broken glass and pipette tips that end up down the sink. So when you're thinking about neutralization and piping and whatnot, think of it as an entire system. You're trying to piece together not only the drainage, but also the venting through roof termination. Polypropylene, PVDF, or glass are the only three piping products. Do I need a pH monitor? Am I confident with what's leaving is going to be permissible by sewer use bylaw parameters? Interceptors, do I have to worry about the students putting things down the drain, etc. So think of it as a system. So on that note, how are we doing for time? I think I didn't leave you very much time, Zach, but so I'm done there, Zach. If
Yeah,
you're
no worries. It's all good. I can get it done pretty quick. I'm gonna give the short version, but I do appreciate, that was always great detail and always a lot of great information. And I'd be happy to let you run along because I know that everyone's getting a lot of great value out of you. So I'm gonna just show really quickly how you can find some of the products and information that we talked about today. Again, my role is more with ATS, and then we have a number of manufacturers that join our services and provide their products to be selected, configured, and downloaded in various spec formats. So one thing I wanted to mention on this, before you even log into your account at atsspec.com, you can go to the Architects and Engineers tab, go to the Learning Hub, and you can get the previous webinar recordings, such as the presentation that we gave today. So if you go to the webinar recording there, you can see all the previous ones that we've done. We had the start of the year, we were talking about, first go and HVAC and navigating the change in the refrigerant, shower solutions, all sorts of different application guides, new products, all sorts of stuff. You can also go back to that Learning Hub and go to the knowledge base. And here, if you search for, say, neutralization, you'll pull up the previous recording sessions that we've had, as well as our sizing acid neutralization guide, which will give you a walkthrough of how to, get your fixture counts, do all the conversions that we talked about today. That'll all be accessible there. You could also search for sizing and get all sorts of sizing guides. So lots of different great information available from the Architects and Engineers tab. And then, of course, you can log in and access your free account. As a reminder, your account is going to be associated across your firm. So let's say, any of the firms that I saw on the call today, TMP, WSP, SNA, whoever, if you got multiple offices, you would be within your office, share projects across your account. So if you're working with the Calgary team on an upcoming lab, then you can go back and forth and make sure that you're all working off of one project file and sharing the information within the ATS spec tool system. I'm going to very quickly remind this quick actions and this toolbar here on the left. So as we go down, we've got our dashboard, our catalog, which will allow you to browse projects and masters, which are your firm's projects and masters, the ATS templates, which is like the ATS masters. There are recommendations for a school, a condo, an office. And then quick specs is the other really important one. A quick spec is kind of just as it sounds. If you're looking for a single system, maybe you're looking for some piping and couplings that we talked about today, you would create a quick spec. You go into the pipe category, or you'd select your coupling category. And then from there, you can configure and select your product. If you were doing more of a complete project, you can see I've got this corrosive waste demo project here. There's a little bit more information that goes into this. We are looking for locations so that we can add any applicable building codes. We are looking for application types so that we can start recommending the appropriate products. And we are looking for a bid date or the tender date, when you're going to market with this, so that you can see I've selected 2025, 0615, up until the 15th of June, we are going to keep this spec up to date. So if Owen and the SMS team change that model number that we talked about from an AN 100 to all of a sudden they're an AN 150 or a OD 150, we are going to keep your current projects up to date. We are going to keep your masters up to date. And we are going to advise you, hey, there's been a new model number selection. You know, this is the new one that you should use. Or, hey, that product's been discontinued. You know, let's have a meeting so we can help you find the right alternative. Once you've created your project, I want to show two ways that you can add product to it. From this add drawing button, you can either hit that create new drawing, which is going to take you back to that category tile page, or my new favorite method, add drawings from masters and templates. So if we need to add a couple of sinks and, you know, maybe floor drains, anything like that, you can see we've got our masters, again, your firm's masters. We've got ATS templates, so the ATS recommended masters for your application. So we can go to our educational facilities template for Canada. You can see we've got bathrooms, suites, change rooms, CAFs, science and lab areas. So we can go to science and lab area. We can grab a quick, you know, sink with the lab spout. We can grab an eye wash. We can grab anything else we need. We will just drag and drop over into our project. Now, if you need to then add more to it from other, you know, application groups, we can go to our drainage or mechanical solutions as well. We can grab a backflow, a water heater, a roof drain, whatever it is I need. And again, just drag and drop. I can organize them as I need. And then once you've got your base selections in there, you can then configure them. So if you need to change the size of the sink from, you know, the current base model to one that fits your specific counters, you can do so. Once you've calculated your acid neutralizer, you can add to this too. We can go back to this categories page, select our neutralization tanks, and find our ANSI here. So if we're looking for that 100-gallon model, you can see it's, you know, so we're refining our selection down. So with a 100-gallon model, only the 4-inch and the 6-inch connection size are available. I can reset that because that goes really quick here. For example, if we were go the opposite, let's say we select the 2-inch. Here we can see there's only the 3 models that have that 2-inch connection size. So we'll go back, we'll reselect our 4-inch. Let's include extension for below grade, our pH monitoring panel. You know, let's put an alarm in here too. And as we are doing that, our model numbers updating, we are getting exactly what we specify instead of the base model. That's the difference between specifying on just, you know, ATS and going to a manufacturer's spec sheet where you get to kind of build and configure it yourself. Once we hit add product, we're going to add the configured model to our project. And we can hit complete. And then we can download, you know, as much or as little as we want. So if we only want to download the one file, we'll just check the box for the one file. If we wanted to download more, we can download more. We can check the box. We can download the entire group or the entire project. So let's just download that waste sink. You can see once I check the box, generate spec docs here in the top right corner comes available. And then you can download it in any of our free formats, submittal, schedule in Excel, Word specs in long or short format, or a CSI 3-part format, Revit content, manufacturer spec sheets, all those details. Now, the most important part these days is getting your masters set up appropriately. If you have your masters set up, your entire team can be working from those approved selections and just doing that drag and drop. It's going to have a higher degree of accuracy for yourself and your team on the system. And more importantly, it's also going to save you a ton of time. So you can download all the files here to get a zip file. We can hit the little individual box if we just want the one file. So if you need help getting masters set up on your system, please feel free to reach out to me. I'm going to stop here because I know we're already running out of time. If you want help getting masters set up on the system, please reach out to me and my team. We're available to help you set up your masters. If you want more additional training on the spec tool itself, we can help you with that as well. Now, importantly as well, most importantly, I would say, if you would like a secondary session, a deep dive into the topic with the manufacturer, please feel free to reach out. We'll loop Owen into a session and we can help make sure that either your specific firm's neutralization master is up to date, or help educate your entire team, help you size and select a product for an upcoming project. So if you need help with any of that, please feel free to reach out to us. Thank you very much for your time today, Owen. Great as always. You always provide great detail, answer all the questions before I even have a chance to ask them. So it was a quiet one for me today, so I appreciate that. And of course, we will have our certificates of attendance out by the end of the week. And if you need help setting up your masters, reach out. Bye for now.
Thanks, everyone. Take care.